So in previous videos we've looked at geometric sequences. We've talked about the application of geometric sequence on compound interest, where the value goes up and up by a greater increase every time, which is a geometric sequence. And now we're going to look at the other application where r is less than 1 but greater than 0. And so what we expect to happen there is a drop and then a flattening out, which you see with reducing balance depreciation. So reducing balance depreciation is the standard way that things would depreciate. Take like a car, for example. You buy a car at, say, $50,000. In the first year, you expect there to be quite a big drop. In the next year, there would be less of a drop. And gradually, as time goes on, the drops are less and less until the point where it kind of plateaus and the value doesn't change very much at all. So this is because the balance or the value of the item, the investment, is going down every time. So the decrease also reduces if you keep the rate of depreciation the same. So we're going to look at this hairdresser salon example now. So a hairdresser salon has equipment valued at this amount, $350,500. The equipment depreciates very quickly at 12% per annum. Find the value of the equipment after 4 years, and they want us to first of all do it recursively. So that means one step at a time. So remember now that the formula the recurrence relation for these sequences is you start off with your V0, and Vn plus 1 is equal to R times Vn. Okay, where R is the 1 plus or minus R over 100. And that's times Vn. So in this case, we're going to do it using a table. So we're going to have time periods year 1, year 2, year 3, and year 4. We're going to type, actually I'm going to type these in. Our Vn is 350, 500. And so the depreciation for this first year we can work out as 12% of the amount. So if we get our 12% and we times it by the 350, 500, that will give us the value of the depreciation. So that gives us 42,060. 42,060. And so to work out the new amount, we need to take that away. So we need to get 350,500 and minus 42,060. So this is the long way of doing this, but we'll show you this to start with, and then we'll show you a much quicker way after that. So 308,440. Okay, 308,440. Okay, and that gets carried through to the next year. So 308,440, and we can keep going. Now there is a much faster way of working out the depreciation where we don't have to work out this column here. So what I'm going to do is I'm actually going to delete that column, and we're going to use instead the multiplier every time. So if I start with my starting amount 350, 500, and I want to times by the multiplier, which remember is 1 plus or minus R over 100. Now in this case it's going to be minus because it's depreciation, and R is 12. So that gives me, inside that brackets, 0.88, because 1 take away 0.12 gives 0.88. So that becomes my multiplier. And that will reduce it to 308,440 in one step. Okay, and this is the recursive way of doing it using the recurrence relation Vn plus 1 equals 1 plus or minus R over 100 times Vn. Okay, and it's much more efficient to do it like this. So that's how we're going to do it for the rest of them. So I'm going to use my calculator to do it. I'm going to get 308,440, and I'm going to times by 0.88, and that's going to get me my next value. So I'm just going to copy paste that in here. Okay, now if I want to do it faster, I can go again to press answer times 0.88, and this means I can keep pressing enter and it will keep doing the calculation again and again. You can show your workings out for it. Now we're going to use the formula to do this a lot quicker now. So you'll know that if the recurrence relation is this, okay, so that's the recurrence relation, then the formula must be Vn is equal to V0 times R, okay, with R being the multiplier, to the power of n. Okay, now we know R is, for reducing balance, 1 minus R over 100 to the power of n. So we're going to use that now. So we're being asked for V4. So V4 equals 350,500 times 1 minus 12 over 100 to the n, which gives us 350,500 times 0.88, sorry, and that's to the 4. Okay, and so the final answer will come out as the same as above, with 210,193.22. Now remember, we should always put our answers as a worded answer, so 210,193.22 is the new value of the equipment after 4 years. Okay, and that's how you do it with a formula.